In this video, we are going to talk about Rolles theorem and the mean value theorem. Okay, so first of all, let us talk about the statement of the Rolles theorem. Okay, let f of x is a continuous function on an interval closed interval a b and differentiable on the open interval a b. Okay, if fa equals to fb, then there exists at least one number c in ab so that f prime of c equals to 0. What does it say is, suppose a function is continuous in the closed interval ab, means between a and b there is no break, okay, and differentiable on open interval ab, meaning the function must be smooth. It is not like sharp corner or cusp, those kind of behavior between a and b. We are not talking about the boundary, just between a and b. If the height of the function at a and b, if the height of the function at the boundary are equal, then what it says is there must be at least one number c between a and b such that the derivative at c is 0. That means the slope is 0, right? That means the slope of the tangent is 0. So can you find out the points where between a and b where the slope of the tangent is 0? Yes, there are, right? Because it satisfies the Rolles theorem. Rolles theorem says that fx is continuous. This function is continuous. This is fx. This is continuous between a and b together with a and b, right? And also differentiable between a and b in the open interval, and the height of the function at a and b. These are the three conditions that the Rolles theorem need, okay? And the height of the function at a and b are equal. Then there must be at least one. There may be more than one, but at least one point c between a and b such that the derivative is equals to 0 at that point c is equals to 0. That means the slope of the tangent equals 0. Yes, there are 3 points actually. At this point the slope is parallel to x-axis. At this point the slope is parallel to x-axis as well, and at this point the slope is parallel to x-axis. You see that? Also you see that you can find at least one critical points. That's what it is saying, right? But the critical points is expanded to not defined as well, and this is also works here. So let's see that the function is continuous between a and b including the boundary, and differentiable between a and b, and if the height of the function at the boundary are equal, then you will get at least one point between a and b. There are 3 points, right? At least one point. Let's denote that as c1, c2 and c3, right? Those are the 3 points. C1, C2 and 3 are 3 points where the slope of the tangent is parallel. Okay, let us look at this example. Is function continuous between a and b? Yes. Okay, continuous. Yes. Is the function differentiable? No. The function is not differentiable at this point. Why? Because there is a sharp corner, right? So here, continuous. Yes. Right? Differentiable. Yes. fa equals to fb. The height of the function at the boundary equal? Yes. Then we are able to find out at least one point where the slope of the tangent is parallel to x-axis. Here, continuous, yes. Differentiable, no. How about fa equals to fb? It is also yes, right? So it does not satisfy all 3 conditions of the Rolles theorem. So we cannot find out. Here, we are not able to find out a point where the slope is parallel to x-axis. So this is the critical point. C is the critical point. But the slope of the tangent, so f does not exist. So we are not able to find out a point C where the slope of the tangent is parallel, but we are able to find out the critical point. So critical point exists here, but the slope of the tangent is not parallel to the x-axis because the tangent or the slope or the derivative here does not exist. At this point the derivative does not exist. Okay, all right, let us do some of the examples, then it will be clear. So that fa equals to fb. What is a? This is a, this is b for this function. Can we apply Rolles theorem? We will see. Okay, so let's do that. So what is f at -1? That is fa. Let's plug in that. You can write that will be 2 and then minus -1 to the 2/3 and then that whole exponent cubed, right? So what do you get? You can get this is 2 minus, you can write -1 squared times 1/3, right? Because that is -1 to the 2/3 can be written as 2 times 1/3 and then the whole to the cube, right? So what is -1 squared is basically +1, right? So what do you get? So 2 minus, you will get root under 2 minus. So this is basically 1 to the third is 2 minus 1 is 1 to the third, right? 1 to the, so it is basically 1 to the third and then root, right? So basically root 1, which is 1. So how about here? So this implies 2 minus 1 to the 2/3 is basically 1. So 2 minus 1 is 1 to the 3. It's 1. So it is basically again 1. So FA equals to FB is verified. Now we want to show, can we apply the Rolles theorem? So we want to see whether it is continuous in the interval and differentiable in the interval. Continuity is obvious because this function is defined everywhere, right? For between -1 and 1, it is defined everywhere. There is no x in the denominator, right? And for any value between -1 and 1, you can write x to the square and then 1/3, so that will make it positive, right? So it is basically, it is continuous, okay? Now the thing is it differentiable at all points between -1 and 1? Let's find out f prime of x. Okay, so basically let's write on fx first. Fx can be written as 2 minus x to the 2/3 to the 3/2, right? So how do you find out the derivative of this? This is like a u to the 3/2. So what is the derivative? This implies f prime of x is equals to n u n minus 1, right, times n u n minus 1, right, times u prime. What is u prime? U prime is the derivative of u, right? So derivative of 2 is 0. So times negative the derivative of x to the 2/3 is 2/3 x to the 2/3 minus 1. So if you simplify this, what do you get? Basically you can cancel these two because 3/2 times 2/3 is 1, right? So that negative will come to the front. So you can write f prime of x is equals to, I would write 3 minus x to the 2/3 to the 1/2, because 3/2 minus 1 is 1/2, times, what do you get? Oh, that negative, I want to write this negative sign to the front. And what do you write here? X to the 2/3 minus 1 is -1/3, right? So you can put that on the bottom, x to the positive 1/3. So is this function, is this f prime of x exist all the points between -1 and 1? No. Why? Because at x equals to 0. So let me write down that at x equals to 0, which falls between -1 and 1, right? F prime of x is not defined, right? So Rolles theorem is not applicable, right? This is what you do. So to check whether the Rolles theorem is applicable or not, what 3 things you need is, we check the differentiability, we check the continuity, and we check the height at the endpoints, okay?